But while it's powerful, isolation forest is not a silver bullet. Like any machine learning model, its effectiveness depends on how well it's tuned, the quality of the data, and the ability to interpret and act on the results. That's why visualization is such an important part of anomaly detection. Data scientists and analysts need to see why something was flagged as an anomaly and whether it's truly an issue or just noise. Up next, let's explore the best visualization techniques for interpreting isolation forest results and making sense of anomaly detection at scale. Detecting anomalies is one thing, understanding them is another. When isolation forest flags an outlier, the next question is always why? Why did this data point stand out? What makes it different from the rest? And more importantly, is it a true anomaly or just noise? That's where visualization techniques come in. They transform raw anomaly scores into something interpretable, helping analysts, data scientists, and decision makers make sense of the results. One of the most effective ways to visualize isolation forest results is through scatter plots. If the dataset has only a few features, plotting normal points in one color and anomalies in another can instantly reveal patterns. High-scoring anomalies often cluster together, making it easy to spot problem areas. For example, in fraud detection, plotting transaction amounts against frequency might show a cluster of normal transactions, but anomalies could appear as isolated points standing far from the rest. But what about high-dimensional data? Many anomaly detection problems involve dozens or even hundreds of features, making simple scatter plots impractical. That's where dimensionality reduction techniques like PCA, principal component analysis, or t-SNE come in. These methods reduce complex datasets into 2 or 3 dimensions while preserving the structure, allowing anomalies to be visualized in a lower dimensional space. A properly tuned PCA plot can separate normal data from outliers, providing an intuitive way to understand where anomalies exist. But what about high-dimensional data? Many anomaly detection problems involve dozens or even hundreds of features, making simple scatter plots impractical. That's where dimensionality reduction techniques like PCA, principal component analysis, or t-SNE come in. These methods reduce complex datasets into 2 or 3 dimensions while preserving the structure, allowing anomalies to be visualized in a lower dimensional space. A properly tuned PCA plot can separate normal data from outliers, providing an intuitive way to understand where anomalies exist. And then there's time series visualization, crucial for applications like network security, predictive maintenance, and financial risk monitoring. If anomalies are flagged in a time-dependent dataset, plotting anomaly scores over time can reveal trends, spikes, or recurring patterns. A sudden surge in anomalies at a specific time of day might indicate a cyber attack, while a slow increase over weeks could signal a deteriorating machine in an industrial setting. The real power of visualization is interpretability. Machine learning models can be complex, but when we see anomalies in a visual format, it becomes easier to ask the right questions. Is this a real anomaly? What might be causing it? Should we investigate further? Good visualization turns raw anomaly detection results into actionable insights, making it possible to separate false alarms from critical issues. At the end of the day, data visualization isn't just about making pretty graphs, it's about making anomaly detection useful. A flagged anomaly means nothing unless it leads to action, whether that's preventing fraud, fixing an equipment failure, or stopping a cyber attack before it spreads. But how do we actually measure how well our isolation forest model is performing? Detecting anomalies is great, but if we're missing important outliers or flagging too many normal points, we need to know. Next, let's dive into performance metrics, how we evaluate whether isolation forest is truly working as intended. Detecting